In this video, we are going to state the laws of logarithms and use the laws to simplify the expressions. Let's take a look at two properties of logarithm. The first property is when you have a log a with the same base a, this result here will give you the value of 1. Example, if we have log 10 with the base of 10, these two numbers is the same, this will result a value of 1. The second property is if you have a log with any base, but this value here is a 1, the result will be a 0. For example, log 1 with the base of 10, this result will be a 0. Again, it doesn't matter what is the value of the base. As long as this number here is a 1, log 1 of any base, the result will be a 0. Let's try some example. The base and this number here is the same, so the result is a 1. Log base 10, 10. Okay, the result is a 1 as well. Remember, when people don't write the base, it means log base 10. This value is a 1. Regardless of what is the value of the base, the result will be a 0. This is a 1. Regardless of what is the value of the base, the result will be a 0. Log 1 with the base of e, the result is a 0. Okay, ln e means log base e. These two values are the same, so the result is a 1. In example 6, we are going to use a calculator to find out the value of each expression here. This is log base 10 2. Your calculator should have a key for logarithm as indicate here as log. Log in the calculator means log base 10. Your calculator only have one single base, which is base 10. Punch this key log followed by the value 2. This means log 2 with the base of 10. Again, your calculator only provide base 10 only. So this will give us 0.301. For this example, the value here is a negative value. Now for log to be defined, this value here, y, must be greater than 0. So for this case, this is not defined. If we try using our calculator, it will give you a syntax errors. Ln 11.18. Now we have a key in the calculator for ln. Ln is log base e. Is here ln. So we press ln followed by 11.18. It will give us the value of 2.414. In some instance, you need to know the value of e. Now if you have forgotten the value of e, you can use a calculator to help you. In the calculator, look for the key e to the power x here. It's a bit small, so refer to your calculator. So it's a yellow color key, so I need to press the second shift e. And to get the value of e, we can key in the value 1 here. E to the power 1 is e, so it should give you 2.718. Similarly, we can get this value from the calculator. It will be minus 5.599. Now we are ready to take a look at the law of logarithms. The first law is known as product law. If you have log xy with the base of a, this single log here can split into a multiple log by having a plus here. So this multiply become a plus. This log xy become log x plus log y. The base will remain the same. Example, log base 10 3x can be written as log 3. This multiply here become a plus log x here. And this is known as product law. For the second law, which is the quotient law, instead of a multiply, we have a divide here. Again, this single logarithm can change to multiple logarithm, and this divide here become a minus. Example, log 3 divided by x, the base here is 10, can be written as log 3. A divide here become a minus log x, the one below. Log x come from the expression below here. Now let's try this example here. Express this expression in a single logarithm. So now we have multiple logarithm here. We want to combine them into a single logarithm. The base will remain the same. A multiple logarithm here you can combine into a single logarithm if the operation between the two logarithm is a plus. Okay, so now the operation between the two logarithm is a plus. We can combine them together and a plus become a multiply. 3x multiplied by 7x cubed. So the result is log base a 21x power 4. Express ln xy as a sum of logarithm. Ln is log base e. So whatever law apply to log will apply to ln. So multiply become a plus the first term plus the second term here. So we have expressed a single log into a sum of logarithm. Express this multiple logarithm into a single logarithm. So we have log a divided by b is log a minus log b. So multiple logarithm here we can change to a single logarithm. The one in front divided by the one behind. 32, the one in front divided by the one behind, it will give us log base a2. The third law of logarithm is known as a power law. The power law say if you have log x to the power of n base a, this power here you can actually bring down to this position here. So become n multiplied by log base ax. Example, log base 2 10 square can be write as, the 2 can bring down here, 2 log 10 base 2. They are the same. Evaluate each of the following without using a calculator. So now 8 I can change to 2 to the power of 3. The reason of changing the 8 to 2 to the power of 3 is because I can bring down this power here. So it's 3 multiplied by log 2 base 2. And we know that this expression here gives us a value of 1. 1 multiplied by 3 will be a 3. Log base 10, 100. So the 100, let's change to the value same as the base. So 100 we can change to 10 square. So that the 2 can be bring down. Now the value here and the base is the same. The base is base 10. So this whole expression gives us a value of 1. 1 multiplied by 2 will be a 2. So the trick is, for this example, change this value here to the value of the base. Example 12. Express this single logarithm in terms of sum and difference of logarithms. Let's deal with the expression one by one. I see this as a divide here first, so that this single logarithm can be changed to a multiple logarithm, and a divide here become a minus here. And this expression comes from the top expression here, which is x cubed y. This expression will be the expression from here. Now I cannot bring down this cube here because there is a y here. But for this case, I can bring down the 5 here. So this will give me 5 log base b z. What I can do is I can expand this further to multiple log. A multiply become a plus. So log base b x cubed plus log base b y. So we can bring down the 3 here. Okay. so this is the answer. Okay, the next example, again, this is a divide. So a single log I can change to multiple log, and the operation between the two log will be a minus. So now this is square root of y, the expression on top, then the expression below will be here. Now square root of y I can write as log y to the power of half. We know that square root is to the power of half. Okay, this one we can split further. 4, a multiply become a plus, but be careful, make sure you put a bracket here. Okay, is subtract away this whole expression. Once this whole expression is split into multiple log, make sure you put a bracket. Later when we remove the bracket, here will be a negative sign. We can bring down this power half here. 4 can change to 2 square. 4 can change to 2 square. Once we bring down the 2 is log base 2, 2. And log base 2, 2 is a 1. So the result here will be a 2. So subtract a 2 here. Minus multiplied by a plus will be a minus. The power 3 here we bring down. And that's the answer. Now we're going to do the opposite. We are given multiple log. We want to combine them into a single logarithm. So let's revise the law again. Log xy, a single can change to a multiple log. So now what we are going to do is we are given this result here. We are going to combine into a single logarithm. Okay. Now when we do that, again the base must be the same. Okay, then we can combine into a single logarithm. Let's check the base here first. Yes, the base is e, the base here is e. We can combine them together. But before we can do that, we have to make sure the coefficient here must be a 1. Okay, the coefficient of this law here must be a 1. So now we have a half here. What we can do is we can bring up this half to the power. Ln x to the power of half. We are bringing up this power half here, plus the 3, let's bring up. It will be a ln x minus 1 to the power of 3. Now we can combine them together using this property here. So ln x power half multiplied by x minus 1 to the power of 3. And x power half we can write as square root of x. We're going to combine this multiple log into a single logarithm. Let's check the base. Is it they are of the same base? This is base 10. This is base 10. Next, check the coefficient. Make sure it's a 1. Yes, it's a 1. So now we can apply the properties. Combine them to a single log. The base still remain as 10. Because this is a minus, so it become a divide here. The expression in front will become here. The expression behind will be here. Now this expression can be simplified further if we were to factorize this expression here. So it will be log x minus y. The x minus y and the x minus y can be cancelled. So the result is log x to the base of 10. We're going to find the addition of these two log without using calculator. So what we need to do is combine them to a single log first. A plus become a multiply. So 2 multiplied by 5 will give us a 10. Now this is base 10 and this value is 10. So they are of the same value. The result will be a 1. Let's try this example. The base is the same. So we can use the property. 1, 3, 5. A minus become a divide. 135 divided by 5 give us 27. Now we are not supposed to use calculator, so 27 what I can do is change to a multiple of 3. 27 I can write as 3 to the power of 3, and this 3 can be bring down, so log 3 become a 1. 3 times 1 will be a 3. We often need to change the base of logarithm. For example, let's say we want to find out the value of log 10 with the base of 2. our calculator will only help us to calculate the value of the logarithm if this base here is 10. So if we want to find out the value of this expression here, we have to change the base here to 10. Then we can use the calculator to help us to find the value. So how to change to the base of 10? We're applying this formula. How to apply this formula? Okay, now we're going to change to the base of 10. So what we can do is we write log base 10 here, log base 10. Then there are two numbers here we need to fill in. The number on top come from here, and the number below come from the base. So now we can key in this value using the calculator, because now is the base is 10, and we can key in this value using the calculator. From the calculator, it gives us a value of 3.32. Let's try a similar example. Again, we cannot key in this value from the calculator because the calculator only gives us the base of 10. So now we're going to change to the base of 10. The value here is 140, and the value here is 3, come from the base. From the calculator, log 140 10 give us 2.146, 0.477. Final result is 4.498. We have seen two properties of logarithms. First is log a with the base a. If these two values are the same, the result will be a 1. The second property is log 1 regardless of the value of the base, the result will be a 0. For the law of logarithm, we have seen that a single logarithm here can be split into a multiple logarithm. Multiply become a plus, and the expression here will be x following the expression here, and the expression here will be a y following the expression here. And instead of a multiply, if we have a divide here, you can split to a multiple log as well. A divide become a minus, and the expression here follow the expression on top, the expression here follow the expression below. Third law of logarithm, we have seen that if we have x to the power of n, this n here can be brought down. So it will be n log x with the same base a. This is n multiplied by log x base a. In the last part of the video, we have learned how to change the base of logarithm. If we want to change the base a here to base b, what we can do is we write this as log base b first. This is the base b that we want to change into, and we need to fill in the value here. The value here comes from this position, and the value here comes from the base. So this is the change of base formula.